In 1946, a deadly chunk of plutonium, known as the Demon Core, was melted down and quietly folded back into the US nuclear arsenal. What sounds like the end of a story was actually the aftermath of one of the deadliest accidents in nuclear history. This 14-pound metallic sphere was never dropped in war, but it still claimed lives. Two brilliant scientists, to be exact. This is the true and terrifying story of the Demon Core, a radioactive killer born in the shadow of World War II. If you thought nuclear bombs were dangerous only when detonated, this video is going to change how you see them forever. The nuclear cores that devastated Hiroshima and Nagasaki, Little Boy and Fat Man, were small enough to hold in your hands. But despite their size, they packed unimaginable power. Because of the intense radiation they gave off, these cores had to be moved in sealed, heavy-duty containers. Still, physicists who got close to them described a strange sensation. They were warm to the touch. That warmth came from the constant radioactive decay happening inside. But here's the thing. On their own, these cores were subcritical. That means they couldn't cause a nuclear explosion unless something, or someone, forced them into a critical state. How did bombs like Fat Man work? They used conventional explosives to squeeze the plutonium core into a smaller, denser form. This process made it exponentially more likely that the neutrons bouncing around inside would strike other atoms, triggering a chain reaction that releases insane amounts of energy. At the center of every atomic bomb is a dense core of atoms just waiting to snap. Like rat traps under pressure, the explosives simply set the first one off. The Demon Core was actually the third nuclear core created during World War II. It was originally meant to be dropped on Japan, just like the others. But after the Japanese surrendered following Nagasaki, the core wasn't needed for war anymore. Instead, it became part of a terrifying scientific experiment. Physicists at the Los Alamos Laboratory in New Mexico, where much of the Manhattan Project was based, started using the core to test the limits of what it would take to reach criticality. One of those physicists, Otto Robert Frisch, had come to the US to study neutron behavior in uranium and plutonium. These materials constantly emit neutrons, and if there's enough of it in close proximity, those neutrons can cause a runaway chain reaction. But you don't even need a huge chunk of plutonium to make this happen. Frisch discovered that if you surround a smaller core with a dense, reflective material, like beryllium or tungsten carbide, it can bounce neutrons back into the core, increasing the likelihood of a reaction. This trick reduces the amount of plutonium needed to hit critical mass. Even without causing a full-blown nuclear blast, it can still unleash deadly radiation in seconds. That's exactly what happened. By 1944, Frisch was in charge of the Critical Assembly Group, a team that began performing what they called tickling the dragon's tail experiments. They pushed cores like the Demon Core right to the edge of criticality to learn how far they could go without tipping over. Richard Feynman, one of the most legendary physicists of the time, said these tests were like tickling the tail of a sleeping dragon. One mistake, and the dragon would wake up. Still, the experiments went on, and within just 2 years, the Demon Core would take its revenge, twice. On August 21, 1945, Harry K. Daghlian Jr., a young physicist, was testing how many tungsten carbide bricks it would take to push the Demon Core into criticality. He arranged the bricks carefully, measuring neutron activity with a Geiger counter. He realized he was getting close and decided to stop. But later that night, curiosity got the better of him. He returned alone to the lab to run another test. This time, he again arranged the bricks to near critical levels. As he moved to remove one last brick, his equipment warned him. If he went any further, the core would go critical. He backed off, but then his hand slipped. He dropped a brick right onto the assembly. Immediately, the core went supercritical. Daghlian saw a flash of eerie blue light and felt a blast of heat. Acting fast, he used his bare hand to knock the brick off the pile, ending the chain reaction. But it was too late. In just a few seconds, Daghlian had absorbed a lethal dose of radiation, one of the highest ever recorded. He fell into a coma and died 25 days later. He was only 24. A photo taken 9 days after the accident shows the burned hand he used to save others from the deadly flash. A security guard in the room, Private Robert J. Hemmerly, was also exposed. He lived another 33 years, but later died of radiation-induced leukemia. He was 29 at the time and had 2 young children. Daghlian became the first official casualty of the atomic age, killed by the very science he was trying to understand. After Daghlian's death, Louis Slotin took over criticality testing. Warnings from Feynman and Enrico Fermi didn't stop him. Fermi even said, "Keep doing that experiment that way, and you'll be dead within a year." On May 21, 1946, exactly 9 months later, Slotin performed a final test on the Demon Core. Instead of bricks, he used 2 beryllium half-spheres. He placed the core inside one and slowly lowered the other using only a flathead screwdriver and his bare hands. This was Slotin's signature method. He wore jeans, cowboy boots, and never used the safety spacers that would keep the spheres from closing entirely. As 7 other scientists watched, the screwdriver slipped. The spheres closed. The Demon Core went prompt critical. There was an instant flash of blue light and a surge of heat. Slotin flipped the top sphere off in a heartbeat, ending the reaction. Everyone else ran, but Slotin told them to come back. He handed out chalk and told each person to mark exactly where they were standing. With this data, he could calculate their radiation exposure and help doctors determine what would happen next. According to a witness, Slotin's first words were, "Well, that does it." He was right. 9 days later, he died in the same hospital as Daghlian on another Tuesday, the 21st. He was 35. The accident was supposed to be the Demon Core's final test before being used in a nuclear detonation. Instead, it sealed Slotin's fate. In those brief seconds, he absorbed over 1,000 rads of radiation, double what people near ground zero in Hiroshima experienced. Since 1945, over 60 criticality accidents have occurred around the world, leading to at least 21 deaths. The haunting blue glow seen in these incidents is a sign of radiation ripping through the air, exciting molecules that release visible light as they calm down. Humans don't get that luxury. Our bodies absorb that energy. Gamma rays and neutrons tear apart our DNA and cellular systems. The result? Vomiting, burns, confusion, hallucinations, organ failure, death. Just 5 weeks after Slotin's death, on July 1, 1946, a new nuclear core was detonated over Bikini Atoll in a 23-kiloton test blast. The Demon Core never saw the battlefield. Instead, it was melted down and recycled into the U.S. nuclear stockpile, reborn with a new half-life. This was the true story of the Demon Core, one of the most dangerous nuclear objects in human history. If you're fascinated by nuclear science, Cold War tech, or hidden stories from WRTU, don't forget to like, subscribe, and turn on notifications. We've got more history that hits harder than fiction. Let me know in the comments. Should the Demon Core have been used, or was it always destined to haunt science?